Have you ever wondered why Roman structures have stood the test of time? The answer to this question has recently been unearthed through groundbreaking research, revealing the secret of the longevity of ancient Roman buildings. The Romans, it turns out, had a pretty unique recipe for their concrete, one that made their architecture resistant to the ravages of time and the elements. Their secret ingredient? Volcanic ash. Yes, you heard it right. The Romans fortified their concrete with a generous dose of this ash, along with lime, creating a mixture that offered an additional layer of protection against environmental factors. But the innovation didn't stop there. Roman concrete had a remarkable feature. It could mend itself when exposed to water, a property modern concrete doesn't possess. Contrast this with our modern Portland cement, which, while it has its strengths, tends to crack easily under stress. The Roman version, however, was imbued with tiny particles of calcium, known as lime clasts. These microscopic components, when combined with the volcanic ash and lime, gave Roman concrete its incredible durability and self-repairing capabilities. We can think of these lime clasts as the hidden heroes of Roman construction, continuously working to keep the integrity of the structures intact. They helped the concrete to resist the destructive forces of nature by filling in any cracks that appeared over time, effectively healing the concrete and making it stronger. This ingenious combination of materials and properties made Roman concrete not just a medium for their architectural endeavors, but a symbol of their advanced engineering skills. The Romans didn't merely build, they built with a vision of longevity and resilience that continues to astound us even today. This isn't just a story about concrete, though. It's a testament to the ingenuity and foresight of ancient Roman engineers. They not only constructed buildings, but also engineered a material that could withstand the test of time, embodying the enduring spirit of the Roman Empire. Clearly, Roman concrete was not just a material of construction. It was a testament to the ingenuity and foresight of ancient Roman engineers. How did structures like the Coliseum and the Leaning Tower of Pisa survive the ravages of time and nature? This question has befuddled historians, engineers, and architects alike for centuries. Yet the answer lies not in some mystical force, but in the sheer brilliance and ingenuity of Roman engineering. Let's take a journey back to ancient Rome, to the grand amphitheater known as the Coliseum. This colossal structure, initially far larger than what we see today, has weathered the storms of time, surviving centuries of damage and restoration efforts. But how has it managed to endure for so long? The answer lies in the unique Roman concrete we discussed earlier. Fortified with volcanic ash and interspersed with tiny calcium particles known as lime clasts, this concrete was incredibly resilient. It could mend its cracks when exposed to water, a self-healing property that modern concrete simply does not possess. This innovative building material, combined with the Romans' architectural prowess, allowed the Colosseum to withstand the test of time. But the Colosseum is not the only enduring symbol of Roman engineering. Let's shift our gaze to the Leaning Tower of Pisa, famous worldwide for its distinctive tilt. Despite its seemingly precarious angle, the tower remains stable. But how? The answer again lies in Roman engineering. The tower's center of gravity is carefully positioned to keep it from toppling over. But that's not all. The tower is continuously monitored to ensure its stability. Engineers carefully measure its tilt and use various techniques to prevent it from leaning any further. This monitoring, coupled with the tower's robust construction, has allowed it to stand tall, or rather, lean tall, for centuries. These iconic structures are more than just tourist attractions. They are living testament to the extraordinary engineering skills of the ancient Romans. They showcase a deep understanding of materials, a mastery of design, and an innovative approach to problem solving that was far ahead of its time. Despite the challenges posed by time and nature, these structures have endured. They have withstood earthquakes, wars, and the steady wear and tear of the centuries. They have survived while countless other structures have crumbled to dust. And in their endurance, they inspire awe and admiration. The Colosseum, the Leaning Tower of Pisa, and other Roman structures are not just relics of a bygone era. They are enduring symbols of human ingenuity and the power of well-applied knowledge. They remind us that with the right materials, the right skills, and a bit of ingenuity, we can create structures that stand the test of time. But more than that, they challenge us. They challenge us to learn from the past, to innovate, to build better, and to create our own enduring legacy. They are a testament to what we as humans can achieve when we apply our knowledge and skills to the fullest. These architectural marvels stand as enduring symbols of ancient Rome's engineering prowess, inspiring awe and admiration across the globe. The legacy of Roman architecture extends beyond the borders of the ancient empire. But what makes it so captivating? The Pantheon stands as a testament to Roman architectural genius. Built nearly 2,000 years ago, this iconic structure continues to astound us with its daring design, innovative materials, and intricate construction. The Pantheon, originally dedicated to all gods, is a marvel of design and engineering. Its most striking feature, the dome, with a central opening, or oculus, represents the Roman conception of the earth. This dome, the largest of its kind when constructed, symbolizes the heavens, with the oculus allowing a shaft of light to illuminate the interior, creating a celestial spectacle. The construction of the Pantheon was no small feat. It required an extraordinary understanding of geometry, physics, and material science. The Romans utilized a unique type of concrete, enhanced with volcanic ash, which enabled them to build the large, unsupported dome. The dome's diminishing thickness and the use of progressively lighter materials as it ascends demonstrate the Romans' advanced understanding of compression and tension forces. The Pantheon's enduring preservation has not only astounded historians, but has also served as an architectural muse, inspiring replicas worldwide. The United States Capitol Building, the Jefferson Memorial, and the New York Public Library, all prominent landmarks in the United States, bear striking resemblances to this Roman marvel. These modern edifices, though constructed with contemporary materials and techniques, pay homage to the ingenuity of Roman architecture, signaling its timeless appeal and influence. Artists and architects alike have long admired the Pantheon's magnificence. Michelangelo, the Renaissance master, is reputed to have said upon seeing the Pantheon for the first time, "It looks more like the work of angels, not humans." Such was the awe that this Roman structure inspired. Its perfect proportions, the harmony of the spaces, and the play of light and shadow within its interior all contribute to its ethereal beauty. It's a testament to the Romans' understanding of aesthetics, marrying form and function in a sublime manifestation of architectural brilliance. The Pantheon, like other enduring Roman structures, serves as a tangible link to our past, offering insights into the Romans' sophisticated understanding of the world and their place within it. It stands as a symbol of human ingenuity, a testament to the architectural prowess of a civilization that continues to fascinate us, thousands of years after its fall. The rich history and enduring legacy of Roman architecture continue to captivate and inspire generations. They are reminders of a time when human ingenuity, coupled with nature's bounty, created structures that have stood the test of time. So, why can't we build like the Romans? The answer lies in the extraordinary blend of innovation, endurance, and legacy that defined their architectural prowess. The Romans, masters of concrete like no other civilization before or since, created a unique blend fortified with volcanic ash and lime. This concoction, unlike our modern Portland cement, had an uncanny ability to self-heal, mending its cracks when exposed to water. This was due to the presence of tiny calcium particles, known as lime clasts, which contributed to the concrete's durability and self-repairing capabilities. Yet, the genius of the Romans didn't stop at their concrete. Their structures, designed with an understanding of the forces of nature and time, have shown an almost unbelievable endurance. From the grandeur of the Coliseum to the peculiar tilt of the Leaning Tower of Pisa, Roman buildings have withstood the test of time, surviving natural disasters and the wear and tear of centuries. Equally as impressive as their durability is the legacy of Roman architecture. The Pantheon's dome, symbolizing the Roman conception of Earth, has influenced architectural designs worldwide. This enduring influence of Roman architecture, seen in replicas of landmarks and marveled at by artists like Michelangelo, can still be felt and seen today. So, while we may not have the exact recipe for Roman concrete, nor the same understanding of architecture that allowed them to build structures with such endurance, we do have their legacy. The echoes of their architectural genius surround us, inspiring us to look to the past in our quest to build for the future. Sure, we might not be able to build exactly like the Romans did, but by understanding their approach, we can be inspired to strive for the same durability, the same sustainability in our modern structures. Because when we think about it, if the Romans could build for eternity, why can't we? While we may not be able to replicate the Romans' exact methods, understanding their approach to building can inspire us to create more durable, sustainable structures. After all, if the Romans could build for eternity, why can't we?